Okay, welcome. This is going to serve as a quick introduction to the VAT 3.0 and Unreal. I'm mainly doing this so that in the future I can check in case I forget some of the settings. It's pretty simple and straightforward, but there are a few settings just to be aware of. So anyway, what we're going to make is something that looks like this. We've got like this mesh, and when you shoot it, it'll destroy, and that's fractured in Houdini, and it's vertex animated. And we're just going to stick to the stock setup. I'm going to kind of, instead of build it from scratch, because that kind of takes a little bit, I'm just going to walk through some of the key features that I have already figured out, and I'll kind of highlight the nodes. So it'll go a little bit faster. So, I import the file and then I transform it. When you bring stuff in from Unreal, you often want to be 0.01. Oh, by the way, to actually get the hydrant, right? You can just do an FBX export from Unreal and then you import that into Houdini. The next thing to note, and the new VAT plugin is great. It actually tells you a lot of this, but it already told me and I already fixed it, so I'll show you. But you don't want to have any extra UV attributes, so this is deleting UV2 because it's going to use UV2. Then polyfill will close any holes, and the last one here is a wrangle. Ultimately, what I'm trying to do is calculate, after it gets fractured, I want the pieces that are fractured to have a certain velocity and to be spinning. And so this sets both of those. In fact, maybe we'll turn that off and kind of illustrate what that does. So then the big note here is RBDMaterialFracture. In fact, it's worth noting that I'm using the RBDMaterialFracture, RBD Configure, RBD Bullet Solver, which are kind of the newer nodes. It does all work. In fact, it's probably more common maybe to use the old DOP network and some of the shelf tools, but I prefer to use the RBD nodes for a lot of work. They have a lot of features. One thing of note too is I've really turned the glue off, so there is no glue. But after fracturing, you can use this exploded node. That's super useful. So you can use this to see, hey, here it is, and you can see how the fracture is, and you can adjust your fracture. Things like the number of points and stuff like that, you can control from each fracture level, and you can hit the scatter points. It pretty much does what it used to do with like a Voronoi fracture, determining points within the volume, but I'm not going to go through that in too much detail because I'm trying to focus primarily on what we need just for Unreal. The RBD configure here, notice it is transferring V and W. I think that's set there by default, but that's the velocity and the angular velocity. And then lastly, we have our bullet solver. One important feature, which I'll highlight on a second time in just a moment, but it's worth mentioning now, is in the output you want to make sure you add P, pivot, orient, and W and transfer the geometry. This is a common bug. This is something I forget all the time, and I'm mainly the main point of this video is to highlight that piece. So remember to set that. And then the last one is just this little sphere out. And if we view it, then we can see it just kind of shatters and explodes. Just to tie into that other node here, if we bypass that wrangle, remember the wrangle was setting the normal to the velocity and then the random angular velocity, then it just kind of collapses, right? So the point of that is you want to give a little bit of explosion to it instead of having it just crumble. So that's kind of the effect of the wrangle. So that's it for the setup here. Now let's glance at the output node. And again, it's not too complicated. It's a lot easier than it used to be. There keeps lots of great improvements here. One thing that I really like is this input tab. It'll tell you what it needs. So here's again is, hey, if you need to have P, pivot, and orient. If you use multi-RPF with slurp, you need W. So it's kind of telling you what you need to include. Another thing that's really useful if you do have an error when generating it. In fact, let's generate the error really fast because it's probably worth seeing what'll happen here. If we turn off this attribute delete, so if I basically bypass that, And you'll see, the net effect of that is that in the geometry spreadsheet you can check out on the vertex tab, there's a UV2. See, right? You can see UV2. So when we try to render now in the vertex animation, it's going to give us an error. And if you hit render, it'll go through. Sometimes, in this case, the error isn't propagating, but I'll show you. You can tell there's an error because when you try to import it, you'll get the FBX just won't work, and the FBX will be really small. So if we glance at the output here, which is in this geo, it's this guy here. So see how it's just 8K? It's too tiny. We got this exclamation point. If you right click this and allow editing and contents, you can go in here and check this out, and there is an error actually inside of the mesh. Sorry, there's an error saying that the UV channel is there. I don't know why the error isn't going up. I just happened to, it had the error before. Oh, I know why. In this node, if you want to check that out, you want to click live update. So this way, it'll be able to show us the inside, and then we'll get the actual error. So there you go. And now when you go to info, it says, this is the awesome part. Hey, invalid source. Do not include the vertex attribute UV2, UV3, or UV4. So what we need to do is just jump back over here, fly into our node, re-enable that. So we're deleting out the attribute. And then if we go back into our vertex animation Rop node, we can export, and we'll hit render all. And sure enough, now when we look at our output, we have some data there. So it's 1900. So let's bring it into Unreal. And again, this is the second main reason of this video, is so that in the future when I try to do this, I don't forget. Okay, hopefully there's a great cheat sheet that that Mai put out for the VAT3, and my advice to you is follow this to a T. So it says turn every toggle off. Now this has caused me lots of grief, so we're just going to exactly do what it says. So we'll loop through all these, turn off all the toggles, because whatever they are, they're probably wrong. I've been burned by this many times, so it's just best turn it all off and then follow it. So then set vertex color to replace. Technically, I think we can use vertex colors now, so this really only applies if we are specifically needing to use the vertex color from Houdini. Let's see, transform vertex to absolute position. We want to turn that on. We've got import mesh LODs. I'm not going to mess with that. That's a new feature that's really cool. Import normals and tangents. Set the uniform scale to 1. Convert scene is on. Override full name is on. Material import do not create, and reorder material FBX is on. And then once you have that, click import. Hopefully it'll do something and you'll be able to see your mesh here. Now notice it's not split up, but if you go to wireframe, you can see it's higher density than just the outside, because that's all the fracture stuff on the inside. So we can't actually see this though until we get our material set up. So we've got one half of the import done. Then the next step here is to just jump over to the textures, and we'll pick the 3 textures that were created, and we bring those guys in. And if you right click, there's a great convenience scripted action, set that HDR textures. You pick that, that'll set the right input textures, and now we're done importing, so we're all good. Then the last step here is we need to set up a material. You kind of only have to do this one time, because like if you were to fracture multiple stuff, you can reuse your material. We'll call this VAT demo mat 2. And in here, it's actually it's great. It's so simple compared to some of the past. You just want to grab a material function, material rigid body dynamics, and wire this guy up. And if we say, hey, give us the color to color, we want to take the normal to the normal, but notice it also says tangent space off. So this is another one of those things. Don't forget, come over here, because basically all this now is calculated in world space, so it doesn't want to use tangent space normals. So you turn that off. And then you want to do world position offset to world position offset. This whole uh, effect is really based off of world position offset. And the last one is these customized UVs. So this, as an alternative, you can maybe use a vertex interpolator for this, but that's extra configuration work. So we're just going to wire it up exactly as it's set up. So we'll bring over 1 to 1, 2 to 2, 3 to 3, and 4 to 4. And we'll apply that and we'll save it. One thing that I've done is you don't want to use this material directly. It's really used to create a material instance. So create a new material instance, and then on the material instance you want to set all of your options here on. Technically I don't think you have to, but the defaults are good, and if you set them, you avoid potential problems. And if we wire in the position, the rotation, and the color, and then we pick the mesh and we look at the mesh, sure enough, if you're lucky, you'll be able to see the mesh exploding. Now in this case, you can see some of the small pieces are flickering a little bit. That particular issue, through trial and testing, I figured if I check useful precision UVs and hit apply, then that will fix that. So now when we look, they're not flickering and they're solid. All right, so that's great, Bob. You got it in. And a lot of times everything stops now. But I think it's important to really highlight this last step as how you use this inside of Unreal, right? So we've got our great mesh, but I want to actually be able to shoot something like we started with the demo. And we're not going to use this one because I already did that one. So let's just create a new one. So what does that look for like? Well, we're going to do as simple as possible. We'll call this VAT Demo BP2. And in here, we're going to make it an actor, and we're going to have it be a static mesh with the vertex animation piece on it. And in fact, if we go into the event graph, we're just going to go ahead and set up what's called a dynamic material instance. This lets you send parameters to a material. So at begin play, we're going to create this dynamic material instance. We're going to use our instance that we set up as our template, and we'll promote this to a variable. And oops. And now we can test the following. When we drag this into the world, then it's gray right now, but if we hit play, it turns white, and you'll notice it's looping and playing. Okay, so a couple things. I forgot to mention the first one. The first one is we really want the color to be kind of like what the color of our source mesh was, and there's a super fast way to do that. I'm gonna just grab the existing asset to save you time. So this is the stock asset, and it has this stock material. And if we look at the material, you can see it literally has a texture to apply that color. So let's just apply that real fast to our dynamic material. There's lots of ways to do this. It's probably best to actually put this as a texture parameter, but I'm just going to hard code it to this material right now for the purposes of keeping this as simple as possible. But I just wanted to have a red hydrant. So now when we have that there, if you hit play, it'll turn red, and then it shatters. Now you'll notice there's a couple problems here. It starts off shattered, which isn't what we want, and it also is looping, which isn't what we want. So I'm going to fix both those things right now. So if we come back to our blueprint, and you can notice on the material itself, it has this auto playback, which automatically plays, and then it has this game time at first frame, and then a playback speed. And so what we can do is, if you set your playback speed to 0, for example, it's going to end up just always being on that first frame. So let's start with that. So we're going to come in here. We can say set a float parameter on the DMI. And the name of that parameter was playback speed. So you come in here and you say playback speed. And we set it to 0. So now when we play it, it's solid. But I can shoot right through it. Well, that's no good. We don't want to shoot through it. Now, I'm not going to go too much into, there's lots and lots of ways to accomplish what we're trying to do here. What I want to have happen is have a collision. So if we make this a little bit bigger, like let's say 50, and we make it a little, adjust the size here and adjust the size here, and maybe pull it up. I'm just trying to get a collision. You'll notice that the existing mesh doesn't have collision on it, and you definitely don't want to use complex collision because it has the interior faces. And it's oftentimes best to sometimes have the original mesh and swap to this mesh, but we're not going to do any of that. We're just going to go, hey, give us a collision box, and then set the collision box so that it responds to all collisions. Without going too far into this, this game is set up so when he shoots a bullet, it does a line trace. If it collides with something, like a visibility trace, then it applies damage. So we can test that real quick, that collision is working by handling that damage event. So there's an event called any damage, and let's just print a string here so we'll test it real fast. I've noticed it's always good to do this because you want to handle and resolve any of the collision issues right away so you don't have to troubleshoot that later. So see how it says hello whenever I shoot it, yay, and it's actually hitting it. So that's a good sign. So we have that. So now we're down to the second to last thing. So now that we're shooting it, we need to kind of do this exact same thing we did, but instead of setting the playback speed to 0, we want to set the playback speed to 1. So we pull that in, we wire it up, and we set it to 1. And there's one other thing we have to do. If we don't do anything, I'll show you what the problem is. When I hit it, it's instantly destroyed. It's not actually playing, and that's because it's already playing far. The time has advanced for it too far. So we can use another parameter value, and if you look at the material instance, it's this game time at first frame, and it's used with that autoplay. And when it's turned on, it lets you specify the start time when the animation is triggered. You can use blueprints or C++ code to set this parameter and use get time seconds. There's a couple different ways to get time, so it's important to use get time seconds. It might be worth glancing in the actual material function that what's going on here if we scroll to the far right in this material, and this material has there's lots to it, but this is the piece right here that we're talking about. So we're setting this game time at first frame because basically it's going to be subtracted from the current time. And so you can see if you set this to like when it's first hit, then it's going to proceed from 0, 1, 2, 3. So time will proceed from when it's shot, which is exactly what we want. So if we go to game time at first frame, in fact, let's copy the name from here because this is another thing is you want to avoid typos. It's kind of a non-typed node. It's all text-based, so be careful typing it. If you type it, sometimes you put a lowercase or an uppercase or something and it doesn't work. And just to reiterate, Mai has a great tip here. He says the actual name of the function that we want is get time seconds. So we're going to come in here, we're going to do get time seconds, and we're going to wire that guy in right there, compile and save. And so now we're almost done. We test it, it's red, it's solid. When I shoot it, boom, yay, it's awesome. But there's one problem, it's still looping. And so we need to go through one last thing. And this is actually, there might be a built-in way to do this, but I'm going to cheat. I'm going to copy this and just put this in for now. There might be a better built-in way to do it, but here's the approach I had. So I have this override. The default is -1. So by default, it's going to be less than B, which is 0. So it starts off at -1, so it's always going to pick this lower branch here. So I'm going to pick the thing we've been doing as the lower branch and wire that in. And then if it's greater than 0, then basically it's going to be this. So this is letting you pick a specific time, right? So basically if it's not set, it's going to be -1. It's going to be like before. But if it is set, it's going to be hard-coded at that time. Now we know from our animation that it was 240 frames at 60 frames per second is 4 seconds long. So what we can do is we can zip over here after we receive damage. Actually, one useful thing too is so you can't shoot it multiple times, put a little do once in there. That's a great little blueprint node. Do one time. And then what we're going to do is pop on a delay for, you guessed it, 4 seconds. Actually, I'm going to go 3.9 just in case there's a little bit of buffer. And what we're going to do at that point is we're going to set a scalar parameter just like before, but we're going to set that one we just added, which is called, what was it called? Override, wasn't it? Yeah, so override. So we'll copy this and we will paste that, and then we will say 4 seconds here. So what we've got here, or 3.9, that's fine. So what we're basically going to, when we shoot it, we start playing, and then 3.9 seconds later, we freeze it wherever it's at. We need our DMI to be passed in here. Okay. So now let's test it out. We go play. We go 1, 2, 3, 4, 5, 6, and sure enough, it's always that way. So now we can have multiple of our wonderful fire hydrants here, and we can flip over to automatic, and we've got them all there. Another trick when you have these, because they always look the same, is to switch the orientation around a little bit. And then this way, when they're destroyed, you won't see the repetition as much. And it looks like more like rubble. And again, there you have it. Low poly, VAT3 in Unreal. Thanks for watching. I hope it didn't go too fast. But in a way, fast is good because you don't want to just have a video that takes forever. Again, if you got any questions, let me know. Hopefully everything was clear in the materials, but I can take screenshots or whatever. All right, see ya.